Hello guys, we are back with our new video. In today's video, we are going to discuss about alkanes, its physical properties, chemical properties and the chemical reactions of alkane. So without wasting any time, let's get started. Let's start with the general formula of alkane. As we know, alkanes has general formula CnH2n plus 2. Well, before that, you already know that alkenes are always written by ene, which represents itself a single covalent bond. What it means? It means all the atoms in the alkane with this formula, they all are having single covalent bond. So let's see how it comes. Let's say if I am substituting the value of N1, then what I'm going to get, it's going to be C1H2 time of 1 plus 2, which gives me C1H4. As you know, it is methane. So if I'm going to draw its structure, it comes to you like this, CH4. Yes, one carbon with 4 hydrogen. So you may see all of these bonds are single covalent bonds. So you may see all of these bonds are what bonds? These are single covalent bonds. So now let's see with that. Next, if I am going to submit N is equals to 2, what I am going to get by substituting N2, I am going to get C2 H2 times of 2 plus 2, which gives me C2 H4 plus 2 6. Now let's draw its structure. When I'm going to draw its structure, it comes to you like this. Two carbons are there. It's understood they are going to have single covalent bond. So let's draw the single covalent bond. Now what about the rest of the 3 bonds of each carbon? That's going to cover by hydrogens. As we can see, we are having here in total 6 hydrogen. Now let's take this. So as I have drawn 6 hydrogen along with the 2 carbons, it's going to give me ethane. So this is the structure of ethane. With 2 carbons, you can get this formula which satisfies that yes, it is a alkane. Now let's discuss about cycloalkanes. Now let's do the discussion of cycloalkane. As we know, cycloalkane, we are having their general formula with us, that is CnH2n. Now what is the mean of cyclo here? Cyclo mean closed ring. Whose closed ring it's going to be? This is a closed ring of alkenes. And what about the mean of the alkenes? We know alkenes represent itself, those are having only single covalent bond. Yes. Now let's see what type of formula or what type of molecules we are going to get by this general formula. Let's say if I am going to substitute the value of N3, because we know the minimum cycloalkane, or you can say the least closed ring, you can see with this formula it's going to be with N is equals to 3. So let's substitute it. It's going to be C3H2 times of 3, which gives you C3H6. Now if you will draw it, it will come to you a closed ring of 3 carbons. Yes, and they should have the single covalent bond like I have already drawn. Now with each carbon we are going to substitute, or you can say we are going to attach 2 hydrogens. So as I am attaching 2 hydrogens, now you may see this is a closed ring of 3 carbons. Yes, 1, 2, 3. So if it's a closed ring, its name is going to start with cyclo. For 3, we always say prop. And for single bond, we are supposed to write ene. So it's going to be cyclopropane. Similarly, we can check it for N is equals to 4. Let's say if I am substituting N is equals to 4, what it's going to be? It's going to be C4H2 times of 4, which gives you C4H8. Now let's draw its structure. It is going to be 4 carbons as it has. Now how many hydrogen with each? We know they have already completed their 2 bonds. You may see here carbon have already completed its 2 bond. One is here, the other one is here. So each carbon is left with the other 2 bonds that we are going to cover with hydrogen. Now let's attach 2 hydrogen with it. As we are attaching 2 hydrogen with each carbon, so by doing that we can see carbon have completed all of its bond. You can see it here 1, 2, 3, 4. Similarly 1, 2, 3, 4. 1, 2, 3, 4, and similarly here as well. So what do we write the name of this? As it has in total how many carbons? It is 4. Very first it is a closed ring. It should be written cyclo. Now for 4 carbons we will write but, and for single covalent bond we will write ene. So it's going to be cyclobutane. Okay, let's do the discussion of the physical properties of alkanes. So the very first physical property of alkane is they are non-polar in nature. Why they are non-polar in nature? Because we know the electronegativity difference between carbon-carbon and carbon-hydrogen bond, that is negligible, or you can say very little. So what's the electronegativity difference we are having of carbon-carbon bond? Of course, it's going to be 0. Yes, because they both are having same electronegativity value. But when we are checking it for carbon and hydrogen bond, you know carbon have electronegativity value that is 2.5, while hydrogen has electronegative value that is 2.2. And the difference between them is, what's the electronegativity difference? If we will check, it is only, you can see, 0.3. So that is negligible difference which will not result any type of polarity. So that's why they are having non-polar nature. Now let's do the discussion of the second physical property, that is hydrocarbons, or you can say alkenes, are insoluble in water. Why they are insoluble in water? Because we know water is polar in nature, while alkanes are, we have already discussed, alkanes are what? Alkanes are non-polar in nature. So as per the organic chemistry law, that is like dissolves like, so a polar component is always dissolves in polar, while a non-polar component always dissolves in non-polar. So alkanes are non-polar, that's why they are insoluble in water, that is a polar solvent. Now let's do the discussion of third physical property. What it is? That is about the boiling point. We know the boiling point depends upon 3 factors. First, that is molecular weight, or you can check, you can see the molecular mass of the molecule. Second, that is about the surface area. Third, it's about the van der Waals forces. You can see it can be of London dispersion forces, it can be of dipole-dipole forces, it can be of hydrogen bonds. So let's do the discussion of this. So when we are checking for the boiling point, we already know it depends upon the 3 factors that we had already discussed. But let's say if you are having any compound, let's say you are having a molecule of pentane, C5H12. You know it has 3 isomers, 3 possible isomers, that is pentane, 2-methyl-butane, and 2,2-dimethyl-propane. So if we are checking the boiling point of these, pentane has the boiling point that is 309.1 Kelvin, while butane has 300 Kelvin, and 2,2-dimethylpropane has 282.5 Kelvin. Now, why they are having different boiling points while they are having same molecular formula? It means if they are having same molecular formula, I can say they are having same molecular weight. So if they are having same molecular weight, how would they have the different boiling points? Let's do the discussion of pentane and 2,2-dimethylpropane. Let's draw the structure of it. So for that, let's draw the structure of pentane very first. So this is the structure of pentane, in which we are having 5 carbons with 12 hydrogens. Yes, so that is the molecular structure of pentane. Okay. Now let's check the structure of 2,2-dimethyl propane. So in this case, what we are having? We are having 2 carbons as a branch here, and the 3 carbons are coming to us as a chain. Now let's arrange the hydrogen with it. Okay. So now what you can see in this case, if they are having same molecular weight, it means the part A of boiling point is not justifying the difference between them. So what we can decide in that case? Then in that case, we will check it with respect to their surface area. Now, if you will check the surface area of pentane, it has large surface area as compared to this 2,2-dimethyl propane, which looks like a sphere. You know, sphere has smaller surface area as compared to this pentane. Here we are having the large surface area. So due to its large surface area, we can say this has high boiling point, that is 309.1, while the 2,2-dimethyl propane has 282.5 Kelvin. So this is the reason 2,2-dimethyl propane has less boiling point as compared to pentane. Now let's go to the chemical properties. So when we are coming to the chemical properties, very first what we are going to discuss, it's about the substitution reaction. Now what is the mean of substitution here? We know substitution take place when one of the hydrogen from the parent chain get displaced by either halogen, nitro or sulfonic group, then it is marked as substitution reaction. So it means basically it's a displacement of one of the hydrogen from the parent chain. So if it happens with the halogen, then it is marked as halogenation. Now let's do the discussion of halogenation. In this case, let's say I am having methane with me, that is CH4, and I am reacting it with chlorine in the presence of diffused light, that can be sunlight, or you can take ultraviolet light as well. So when we are doing it, you can see here hydrogen is going to behave as a good leaving group. So chlorine will take the place of this. What it's going to be? It's going to come to you like this. So you may see here one hydrogen has displaced by chlorine. So what's going to be this? We can write its name as chloromethane. So you can get chloromethane from methane. So it is a halogenation in which one of the hydrogen get displaced by halogen. Now let's do the discussion of the next. Okay, let's do the discussion of combustion reaction. So what it is, in the combustion reaction, we already know when hydrocarbon gets reacted with the full supply of oxygen, they will show the complete combustion. What it results? Which results the formation of carbon dioxide and water. Along with that, it releases a large amount of energy. It's about complete combustion. But if we will supply the less amount of, you can say the least or the very less amount of oxygen, in that case it's going to give you carbon along with carbon monoxide and little amount of carbon dioxide gas and energy. So this is the example of incomplete combustion. So we can see both. It depends upon what amount of oxygen you are providing to the hydrocarbon. If you are providing the complete supply, the full supply of oxygen, then it will result carbon dioxide and water. But if you are supplying very less amount of oxygen to the hydrocarbon, it's going to result with a lot of minor products such as carbon, carbon monoxide along with carbon dioxide and water. Now let's talk about the control oxidation. So what is a control oxidation? It is a regular supply of oxygen with at high temperature and at high pressure with some catalyst. So when we are doing some chemical reaction with the help of catalyst and under the condition of temperature and pressure, it will result a required product. Like if I want to form in this reaction alcohol, so what I will do, I will treat methane with the regular supply of oxygen in the presence of copper and at 523 Kelvin temperature and 100 atmosphere pressure, then it will result the formation of methanol, which is an alcohol. Similarly, let's say I want to produce aldehyde from methane. So now what I can do in this case, I am going to again supply the regular supply of oxygen to the methane, but now this time I am using molybdenum oxide. Which catalyst I am using? Molybdenum oxide, which help to get me the aldehyde. So these are the mild oxidizing agent which will help me to get the different functional group from the alkenes. Now let's do the discussion of next reaction. So what is the next reaction we are having here? Okay, let's talk about the fourth type, that is isomerization. We know isomerization is that when we are changing hexane, or you can say any alkane, normal alkane, to its branched structures. So how can we get it? We can get it when we will heat it in the presence of aluminum chloride and hydrogen chloride gas. So here you can see we have converted hexane into one of 2-methyl pentane and the other is 3-methyl pentane. Might be one question comes to your mind that we are having in total 5 possible different structures with the hexane, but here I have written only 2 because these 2 are the major products under these conditions. So we are supposed to write only the major products in the organic chemistry. Now let's come to the aromatization. What is the aromatization? Aromatization suggests when we are forming any aromatic compounds. How can we do it? Under the aromatization, we have to take care only the alkanes with 6 or more carbon atoms when it get heated at high temperature and under the condition of the pressure in the presence of some catalyst like chromium oxide, vanadium oxide, molybdenum oxide, they can produce the aromatic compounds such as benzene and they will release hydrogen gas. That's why it's written they are dehydrogenated. They will remove the hydrogen gas during the formation of aromatic compound. Thanks for watching my video. Don't forget to like, subscribe and share.